Now, when you look at placing the sensing device in the neutral, then we take 42% of the overcurrent protection device rating that we are going to use and connect in the transformer's neutral connection. And you know, when we deal with high impedance grounded systems, we had to review 250.36 as well as the exception to 450.5B2, and I suggest looking at 110.9 and 110.10. But now, reviewing this figure that deals with placing that sensing device and the neutral to sense, then we want to look at our figure 20-14, which again, we obtained this figure from Stallcup's Volume 2, Designing Electrical Systems. Now you notice in this illustration, 20-14, we're taking 42% of the zigzag amps that you see in the illustration here to the right, bottom side of this illustration. Now everything else is the same as it was in the previous illustration, 20-13. However, we're going to do a little bit different design work when we look at the boxed in information with the title head, Finding Phase and Neutral Current to Trip Open the Service Overcurrent Protection Device. Now notice in step 1, we took 125% of that 100 amps, and 125 amps was placed, and what I shouldn't say placed, but sized the overcurrent device for the service. Now we're finding the sensing device, we're placing it in the neutral current also. And notice in step 1, 450.5B2 little b, we take 42% of the 100 amp zigzag transformer rating. We come up with 42 amps. And so in the solution, a current of 42 amps or greater will cause the service overcurrent device to trip open if the neutral started sensing this kind of current where we have placed that sensing device in the neutral that we have provided. So that's what this illustration 20-14 is showing the designer as well as the installer just exactly how that sensing device placed in the neutral that was created there to sense that value and open up the service overcurrent protection device of the zigzag transformer.